Welcome to Ask and Learn.
In this problem, we have a cylinder which is initially filled with nitrogen gas at a specified state. The gas is then cooled by transferring heat from it, and we wish to calculate the amount of heat transfer in this process. We assume that the cylinder is stationary and hence there is no kinetic and potential energy changes. There are no work interactions other than the boundary work. The thermal energy stored in the cylinder itself is negligible. The compression or expansion process is quasi-equilibrium, and we assume that nitrogen is an ideal gas with constant specific heats. So the gas constant of nitrogen, R, is equal to 0.3830, and that's psi foot cube per pound mass R. The average temperature of the gas is 700 plus 200 over 2, which is 450 degrees Fahrenheit. And the specific heat at constant pressure at this temperature is 0.2525 BTU per pound mass degree Fahrenheit. These values are from our tables. Now, since this system has no mass entering or leaving, it is closed. And we can write the energy balance equation, E in minus E out, is equal to the change in energy in the system, delta E. Now, the energy out is due to the heat that is leaving the system, so it's negative, minus the boundary work out of the system. And this is equal to the change in internal energy of the system, delta U. So we can write delta U as M into U2 minus U1. And so if we take the boundary work across, we get that minus Q out, the heat that is leaving the system, is equal to M into the enthalpy change, H2 minus H1. And this can also be written as M Cp into the change in temperature, T2 minus T1. So here we have our our energy balance equation. Now, the first thing we need to do is find the mass of the nitrogen so that we could use this equation. Now, the mass of nitrogen is equal to P1 times V over R T1. And the pressure we know is 40 psi absolute times a volume of 25 cubic feet over the gas constant 0.3830, and that's psi foot cube per pound mass R. We'll suppress those units, times a temperature of 1160 R. Hence we get the mass of nitrogen in pounds to be 2.251. So the mass of nitrogen in this process is 2.251 pounds. Now, we can use this mass and substitute it back into our energy balance equation. So we can go back to that equation and find this Q out. Q out is the mass, 2.251, and that's in pounds. Again, we'll suppress the units, times C, which is 0.2525, times the change in temperature, 700 minus 200 degrees Fahrenheit. And so we'll get our answer in BTU. So we get the heat transfer for this system to be 284.2 BTU.